different OSs, if you are attaching like a CD, does it also attach in parallel for other operating systems, ISO files?
How is that? How is that happen? It won't happen, right? You're attaching, first of all, what you asked is you're attaching a CD. That's not correct. You're attaching an ISO file
ISO
to the
file.
CD
Let me
ROM.
put in this ISO file.
Okay, you're attaching an ISO file to the CD-ROM so that you can access it through the ISO CD-ROM file. That is the way you have to talk. Now,
So
you're
if
attaching
you
an
only
ISO.
one.
Listen to me. You're attaching an ISO file for a particular operating system. For Windows 7, Windows 6, every operating system has its own ISO file. So there is no question about when you attach Windows XP, it's not going to show you Windows 7, right? You can do one thing. You can club 4 or 5 ISO files together and you can make it a big bundle and then you can attach it. But that's a different thing. In that case, it's not going to be a bootable thing or anything,
Okay. My question is, when you have 50 or 100 VMs on a machine on ESX, if you wanted to install multiple operating systems in parallel, is there a possibility?
You have to go through each one of them. There is no way you can do that 100 machines together. No.
Okay.
But there are other ways of deploying operating system. We will learn that is called templates and also we will look into that. But
Okay.
to install
so the cloning also similar to templates?
no. Cloning is different. Cloning is a totally different concept. Template is another concept. I did install it. Why is it asking me? So anybody install any other ESX 96 is there, huh? That is what you're saying. See guys, that is not possible. Okay, see, I cannot install these servers. If you don't install them, that is it. I will teach with one box. It is definitely important that you have to install all servers, okay? And VMs are also needed. And again, even this one, Sujan installed, I'm not happy with the way you have done this. This is actually a DHCP IP address. That means you didn't know how to configure an IP address. Once you finish installing an ESX server, you go to the ILO, you go to the properties and change the IP address DHCP to a static and put a static IP address, right? You're supposed to do that. So is 101 is the only box and
ideas like that.
So this is static IP?
Yeah, that's a static. All the IPs, 98 IP was, it's conflicting because I tried so many times and it's not showing the users, but if you ping it, but it will ping. Now it's stopped. So it's like that. It's all stats IP. It's not a manual IP. The 101 is a vCenters IP because I installed vCenters on this, VMware. So that's what.
vCenter?
Yeah. That's a 101 is a VM vCenter, so that's what it's asking something to install.
I'm not understanding what you're talking. I didn't even teach anything about vCenter. Then how do you install vCenter?
No, I was trying, you know.
Okay.
You try 137. It's working perfectly.
See, I mean, you guys at least try to do what I teach. Forget about vCenter and all those things. That is all later we will look into it. At least try to do the things what I teach. At least try to do that correctly. So we have a lot of things, things.
Hi Deepak, this is Satya. It's better to connect any other IP item remote desktop. So we can see the everyone. I think IP 19 also installed 3 servers: Windows 2008, Windows 2003, and Ubuntu also.
Deepak, I gave you the wrong IP address. Actually, it's 97.
Satya, I didn't understand your question. Okay, I'm sorry. I was focusing on this, but I didn't understand your question. If you can put that question in a correct way, I can possibly try to answer your question. But unfortunately, I didn't understand whatever you said. I'm sorry about that.
Actually, I think I saw many guys are different operating systems, Solar, Linux, and CentOS and Windows. But I think there's a problem with IP addresses. We can see. I saw that I would like to try to install.
I'm losing you. Okay, hold on, please. First of all, you're not clear. Let me try to understand. What are you saying? First, talk. Let us talk line by line here. Let everybody understand what you're trying to talk. Okay, so now let us start.
Just now we can connect to the ILO just 19.
Oh, you are talking a lot. Now you are saying ILO. You didn't say ILO earlier. So what is? Okay, try to explain your thing in your mind. Okay, let me hear. Okay. Go ahead. Satya, go ahead. Speak, please.
Yes. Okay. Actually, now before starting this class, I saw that I connected to host IP address 19.
Okay, so let me tell you before starting the class. That means maybe an hour back.
Not
you connect
at 8:50 like that.
So you are saying before starting the class, you try to connect to what? Connect to what?
IP address 19.
Okay, please speak very slowly, okay? Please speak and talk to what I'm asking. I need only answer. I don't want you to explain the whole thing. I want you to give me answers in very precise flow. Before starting the class, you connected to what?
No, ILO 19 actually.
Okay. Wait. You connected to ILO 19. Understand? That was a DL385G2 server.
Yes, in that
Wait, please, man. Wait, listen to me. I cannot understand. That's why I'm trying to understand you. I'm trying to help you out here. So you connected to that server using ILO, correct?
yes.
Did you see the screen of the server?
18, not 90, sir. 18.
Okay, till
Right.
this time you talk 90. So you connected to 18. So now fine. Okay.
Yes.
Now you connected to 18. What did you see there?
Yes, Raiden is installed Windows 2003.
Come on, I don't. Correct?
Yes.
That is the ILO. Do you know what is the difference between an ILO address and a ESX server IP address? There are two different things. Do you know that?
Oh, yes.
Because I'm frankly saying I'm not understanding. I know nobody else is understanding what you're trying to tell you. I'm not trying to put you down, but the thing is, the way you're talking is totally, I'm not understanding. So you are saying you connected to ILO 10.10.80. That is a DL385G1 server. Now what happened?
After that, just I saw that one in that ESXi 5.1 is installed.
Okay. What was the IP address of that ESXi?
Okay, yes, 10.10.10.97.
Okay. So then what did you do?
Yes, in that already it is 3 VMs are there.
How do you see 3 VMs are there? By using ILO, you cannot see any VM. So you started VMware vSphere client and you connected to half of your things in your mind and talking. That I cannot read your mind. Okay. Answer. That is why I'm telling answer to my question. So you connected to ILO first. So why did you connect to ILO first? Tell me that. Why did you connect to 10.10.80? Tell me why did you connect it to 10.10.80?
No, whether it is the DSS server is installed or not, just 5.1
Okay.
is there.
Fine. Now that is a good point. So you connected and you made sure that it is installed. Then you saw the IP address is 10.10.96, correct?
No, after that, yes. After that, I've opened vSphere client and connected to
Connected to what?
just 10.10.97 and root and password.
Okay. So what did you see?
After that, it is Raiden is installed 2K03, 2K08 and Raiden Ubuntu. He installed 3 VMs.
Okay. Not he installed, it was there. He installed or not. I can also create Raiden 201, but when you connected, you saw there are 3 VMs, correct?
Yes, correct.
Okay. What did you do?
Yes, I tried to do as Windows 2003 with my name is Satya. Actually.
Okay. So you created a VM and then did you install Windows 2003 on it?
Yes, not that I created actually. Just, back only I started that one actually.
Okay. Fine. Okay. Now what was your state? That's all good. So what was your host state?
The conflict of IP
Address you ping. Okay.
Correct. Yeah.
So, I mean, I told you to find out like this. Now, what is your question is you are asking, is there any way that we can find out all the IP addresses? Is that what you're asking?
Not like that. Someone has created VMs on this machine. I am telling that actually.
Okay, that is good, right? We wanted everybody to create VMs.
Yes.
Correct, Satya.
Yes. Okay.
So I didn't understand anything. So you had some question, but now you are not asking that question. Fine, okay. Leave it. Okay, if you have a question, always call me on the phone. We can talk over the phone, okay?
Okay, thank you.
Okay, Deepu, I'll explain you what happened is all these days, you know. So what happened is, so you define 4 IP, right? 4 to 5 IP, 95 to 99, right? So what happened is everyone is running there without information. When you are working there, they'll restart the server. Either it's gone through the ILO or it's, you know, through the
Okay,
VM.
here's the thing. Okay, here is the thing. Let me tell you.
It's having a lot of problems. That's what I also manually changed the IP to another directions, and then I installed. You know, then it will be
Understand. My machine is also frozen. Okay, what is going on? Okay. Yeah, this is my DHCP server, okay? Not my DHCP server, this is the whole lab's DHCP server. In this DHCP server, I have some problems already there. If you look at it from IP address 100 to 150 is configured as a pool. So whenever people connect, they're going to get an IP address between 100 and 150. Remaining IP addresses can be used. Out of the 255, these 100 IP, 50 IP addresses are going to be assigned DHCP. I have some reserve. I don't think I have any reservations. Okay. So that's fine. So what you need to do is, this is what you need to understand. IP addresses from 10.10.10.151 onwards actually can be used. But there are some servers that I have with 150, 151 and all. So what I am telling you is this. You guys, for 4 ESX servers, ESX or ESXi servers, there are only 4 servers. There are only 4 servers there. Remaining servers are not given to you. Please use IP address between 90 and 98, that or 99. This is what I was telling. That means they are in the static range. They are not part of the DHCP. 90 and 90, you have 9 IP addresses. For VMs, if you are building virtual machines, Windows or Ubuntu or something, when you build it, automatically it is going to get a dynamic IP address. That means it will be an IP address between the range 100 and 151. Correct? You can use that, but I don't want to use DHCP. I want you to go to the network card properties of the VMs you build and change that IP address and put an IP address between the range 60 and 90. That's enough, right? Now you have a lot of IP address.
Yeah.
Please use that. That's all I'm saying. So use IP address between 60 and 90. Now again, simply don't go and give, okay, oh, Deepu said 60 and 90. Let me go and give an IP address 75. So you cannot do that. Ping 10.10.10.75 and see whether it is pinging. You want to give 78, give 78 and see first it is. If you do this and you configure, there will not be any IP address conflict. If you are not checking and just on the fly you are going and giving an IP address, then it is a problem.
Yeah.
You understand what I'm trying to tell you here?
Yeah, I know very well. Yeah.
Anybody having any doubt on it? Is this clear for everybody, guys? Don't use, I don't want any servers or any VMs between the IP address 100 and 151. I don't want, because that is DHCP. And I don't want you to configure anything above 151 also. Please use IP address from 60 to 90 for your VMs and 90 to 99 for ESX servers. Why I am telling like this is, coming days we're going to learn about ISKC and things like that, vMotion and all. We need IP addresses. And those are required for many other things. We need to configure ISKC with IP address. We need to configure. So I don't want to have a mix. So there has to be certain standard. That is why I'm trying to tell you. Okay? So there should not be any conflict. There will not be any conflict if you are following this rule. Just ping the IP address, make sure it is pinging or not. If it is pinging, you should not be using that. Clear? Okay, now I'm going to connect to 101. 101 is actually a static IP address, he is saying, but it is not a static IP address. This is a DHCP range, correct? According to you saw that DHCP server. Then there will be a chance for a conflict. Then there will be a chance for conflict because we don't know whether DHCP server has given that IP address to somebody. And Sujan has put 101. And that is why probably there is conflict. You understand what I'm trying to tell you? So 101 is in the DHCP pool. That is the pool that is DHCP is supposed to give. So DHCP would have given 101 to some of my other servers. See, no, that is a different problem. What is the password you given?
This is a VM Center. VM Center is a VMware. You try 137. 137 is a.
I mean, others are not speaking. Okay, this. What is the password here, please, for this? What password you give?
Go to 137. Try 137.
No, I want to go to 101. What is the password? That is an ESX server. What is the password you give?
VMware, the default password.
I never told you to give in VMware.
No, this is a default one. So I installed this from your template, so that's what.
What? Don't take me wrong. Okay, let me tell you something.
Okay.
When you go for an interview, listen to me. Okay, this is for everybody. When you go for an interview, just at least for that interview perspective, think that the person you are talking is at least smarter and better than you. Please think in that way. Otherwise, you're going to be in trouble. Mm-hmm. Now, you are trying to tell me that you installed from template.
Yeah.
You installed from that. Are you teaching me that?
No. I
don't tell me that. I know what has happened. Okay. Don't tell me that. Okay. If you try to if you are attending an interview, even if you answer all my questions, coming questions, I will not take you to my team because I don't like you. Because the way you are talking, you are a liar. Because you are trying to make me teach you. I mean, I'm not saying here, I'm trying to explain everybody. Don't lie. If you don't know, you say you don't know. If you do a mistake, you say I did a mistake. So now you are saying, from which template? VMware don't have anything like that. There is a password for VMware. You put that password as VMware. Correct?
Yeah.
Isn't it? And you are trying to teach me, correct me. No, it came from template. Huh? I mean, if you do that, I don't have a problem, but I'm telling you, when you go for interview, you do the same thing. And that is more than enough to piss off that guy. Okay? Mm-hmm. He will not take you, I will bet you. If not only me, everybody has that thing. That's a human tendency. I don't want to take a guy who is the first day itself trying to teach me or trying to lie me. And you can teach me as long as you think you are 100% right. But now you are saying is you change the password and now say, I told you everybody put the password because I want your server to be used by others also. Now anybody will be able to connect. You create a data center. Who told you to create all these centers?
No, I was trying, when I finished the VMware, then I tried this one, so.
And now where is the server here? You call this as a server. I don't know what you did. I never seen somebody. This is a vCenter.
That's what I
you
told
installed
you.
vCenter. This is a vCenter.
Yeah.
So you're wasting everybody's time. I mean, I don't know who told you to install vCenter and all. Come on.
Deepu, can you try IP address 96 and 97? I think we are losing a lot of time.
No, I'm not
Those are the
connect
missions.
no, I'm not doing anything, guys. You guys figure it out. I'm going to start teaching your stuff. I mean, that's fine. You guys figure it out. If you want to install vCenter, Sujan, why do you attending this class? You can do it in somewhere else, right? When I teach, you do it, right? All this time you wasted because that was not an ESX server. It's a vCenter. So. At least, in that sense, you should tell me that's a vCenter. I mean, I would have been more than happy if you would have come and asked me some questions related to VLAN or something like that. I didn't talk about VLANs. Did anybody ask this question? Nobody asked me that question so far. Right? I finished networking and I'm going to start storage today. Did anybody ask me? You didn't talk about VLANs. What is VLANs? Did anybody ask me? And rather, you are going far, different things. That's not the way. Okay, whatever I teach, please try to understand that fully and then come back questions on that. I don't want you to tell me other stuff. That we will deal later. Oh, please. Half an hour is gone. Sujan, do you know what is beacon probing means? Sujan. Yeah, forget it. Okay. Yes, there is no class tomorrow. Let me tell you something here. Okay. Aravind. Okay, let me do that first. I don't want confusions here. And I don't want anybody to install vCenter and all. vCenter is something I didn't teach, okay? And Sujan, whatever you install, delete that, okay? I don't know, wherever it is. Okay, Aravind, Satya, and Becker. You guys use 10.10.10.17 server tomorrow. Okay? Install ESXi5 and create 2 VMs per user. You guys got it. That is only your server you guys going to use. If you already see whoever is connecting to 17 and if you see there is already ESXi5, just assume that is installed by Aravind or by Satya. All you need to do is connect to vSphere client, start creating your VM. That's it. Don't reformat. If there is an operating system there, ESX is there, don't do anything. ESX means reformat. I need ESXi5. Okay. Pani, Raiden, and Samrat. You guys use 10.10.10.18. Do the same thing. Sri, Jean, Sujay, and Santosh, I'm also putting you in that.
Okay, Dixit.
Okay, you guys build 10.10.10.19. Okay, 10.10.16 is currently down. I will fix it. That I will be ready tomorrow, and I will send you an email, or I will build it myself. Don't worry about that. These are your servers. So Aravind, Satya, and Becker, you are not supposed to touch these two servers. Okay, this is your server. If you have a problem connecting to that server, if you have a problem installing that server, call me. Anybody having any problems connecting to the server or installing, and all I need is ESXi5 and at least 2 VMs for Sunday's class. It is absolutely needed, otherwise we cannot proceed. Is there anything doubt on it? Okay, I can also give you something here. Okay, give the IP address, I don't need to tell you. I already told you 100 times now. 90 to 91, ping and make sure. Any doubt for anybody on this? Okay, I put it on the chat window, okay? If you want to take a note of it, these are your servers. I cannot hear. Somebody is trying to talk. I think I cannot hear. Okay, who is talking? Yeah, right, and I cannot hear anything, man. No, neither me nor anybody.
Deepu, Arvind here.
Yeah.
Deepu, can you hear me, Arvind?
I can hear you.
Yeah, basically, on IP17, we already have ESX 5.1. Do you want us to go down to 5.0?
I didn't say 5.0. I'm saying ESXi 5.1. Sorry.
Okay, it's already there, and also we have a couple of VMs already created.
Okay, then
So
you don't have to do it. Then you don't have to do anything. Then you can leave it. But make sure that the VMs have static IP address and they are configured properly with VMware tools installed. I showed you all the things.
Yeah. Other than the making as a static IP for the VM, remaining everything is within the same norms, like the password as well as the other things.
And all the servers, please build all the servers with password as password. And for the Windows and Ubuntu Linux machines, if you're building, the password should be welcome1 with a capital W.
Yeah, that's what I have built.
Okay, I wanted to ask you to do any preference on what OS. I prefer to build a Windows 2008 VMs. If that is the remaining is your choice. I don't have anything. I prefer to build Windows 2008 or R2 or 2008, 64-bit or R2 is only 64-bit. But if you're building 2008, you can build 2008 64-bit or 32-bit. Doesn't matter. If you want, you can install a Ubuntu also, but I'm not going to look into that. But I need Windows servers at least from every user, okay, on these VMs. So Aravind is already built it. Satya and Becker, you can connect, you can build your own VMs, okay. And also I mentioned when you create a VM's hard drive, always select that thin disk option, okay, thin disk. When you create a VM, always select that thin disk option. It is important to do that thing this because then only everybody can create VMs. Okay. So Aravind, don't worry about it. Whatever is there, let it be there. Don't delete it. If there is a VM from Aravind or Sri is there, let it be there. You don't have to do that. You build your VM. Okay, guys. So let us start here. The storage part. I just want. I wanted to move forward. Okay. Storage. Storage, I'm using this 3.5 study guide here for the storage. The reason being, the storage part explained in this book with the pictures and all, I think it is much more prettier and it's much more easier to understand, and that is why I'm using this. We will be doing storage, we will be doing the configurations, everything of storage using the 5.1 server, but the concept of everything is same. So I'm going to use this book. You also have this copy. If you want, you can actually look into this. Okay. So storage module itself is around 5 chapters. So first lesson is actually the fiber channels and storage. That is what I am trying to finish. InfiniBand is one of the latest storage technology which is started using. It was only used in supercomputers and all, but now slowly it is coming into the IT, normal small and not small, I would say, enterprise companies, Fortune 100, Fortune 1000 companies started using a little bit of InfiniBand. Again, that is not in the scope of this, but anybody wants to read about InfiniBand, INFINI, InfiniBand. That is another storage technology. So we're going to focus on the fiber channels and storage.
Deepu, is compellent storage fall under any of these categories, or is it a separate storage?
No, compellent and all, that is actually the storage. It's a different type of storage, but that's actually a Dell piece. That is not, that's a name, but the protocols is what we are talking about. The storage can be from NetApp, or it can be from EMC, or from Hitachi, or from, so everybody has 3PAR, Dell storage is actually compellent. I think that the protocols is what we are talking about. So storage can be from different vendors.
Okay.
So who is, who is working on storage in this class? Samrat, is that you? I know one person is working on storage. So what type of storage are you working on? Arvind, what type of storage you deal with? Okay. Clarions. Only Clarions? Okay. Okay, Arvind is saying TSM. What is TSM? Tivoli? Okay, VMX, VNX. Okay, that's fine. I'll talk about that. So before going here, let me take you and show you some storage thing, storage arrays. They are not storage. So let me go to Google, show you some storage stuff here. So storage. I'm talking about storage. It's a generic term, storage. Or SAN and all people say, but there are different companies that are completely into the storage technology. EMC is one of them. HP has their own storage. Dell has their own storage technologies. NetApp is another major vendor in the industry. Hitachi is there. So I just want to take an example of EMC. EMC is one of the leading storage companies, and you know that VMware itself is owned by EMC. EMC has a lot of product. They have different line of products. Clarions is actually their one of the famous EMC. Clarion is very well famous storage technology, but that name is now changed. They are using something called VNX. That's what actually Samrat said. So if you can see different storage arrays that are actually called as the storage arrays. If you go back, let me go to one more thing. HP EVA. These are some HPs. If you look at these are some HP storage arrays. Let's try to take a picture here and try to explain this a little bit here. So this is how a storage array look like. There is a lot of hard drives and things like that are here that are attached to this whole rack. You can see a lot of hard drives, and then in the middle you can see that there are two servers, or you can see that these are basically the storage controllers. this contains the operating system to manage this whole storage array. So the storage administrators basically connect to this. They will be having different interfaces, web-based interface or other interfaces. They connect to this controllers. Typically, there will be 2 or more controllers on a storage system because it's a highly redundant environment. You can imagine if your server, if this array fails and the hard disks are not available, you can imagine what happened to your entire environment. Your data center will go down if this whole thing goes down. So it's a very critical environment. So deployment of that and the management of this is very, very critical job. So SAN administration is don't take it as simple as that. It is actually a very responsible job, I would say. So these are this is an HP SAN. So you can see that the 2 controllers. This has all the operating system and all. And these are the hard drives. So the SAN administrators connect to this, and they make or carve different RAID 5, RAID 50, RAID 10, whatever they can do. They make different combinations of RAIDs, and then they make it as LANs. We will talk about that. So they manage all these hard drives. It can be multiple arrays. This is only one rack. Maybe multiple arrays can be attached together and managed by using the controllers. This is actually the back side of an HP EVA SAN. You can see that all fiber optic cables, it's all fiber channel cables. And these are actually the fans and the disk controllers and all at the back of it. So if you are seeing the back side of it, this is what it is. So HP has many things. You can see that these are all different HP SAN arrays. You can see that.
Deepu, what are used in this one same as the IDE and SATA drives that we use, or is it completely different?
It can be different combinations. It depends on, there is no IDE drives, but SATA and, fiber channel disk, and nowadays even SSDs are coming up. So it can be any combination. That's all, and different speed also. There are 10K drives, 15K drives, things like that. So they can put different combinations of drives in it, and they manage it. So this is another picture of a HP SAN. You can see that, these are all the different drives. I think these are all EMA. That's not the correct picture. Anyway, this is a very old thing. EA is gone, but I am not very familiar with it. Let's go to EMC things. So EMC has, much more, see that their things are all looking good. This is actually an EMC Clarion system. This you cannot see all this in the behind. These are the disks you can see. In one of these row there will be the controllers. And there will be a lot of drives in this particular thing, and it can be racks and racks. So this is how it looks like. So this you can say this is actually a EMC storage array. That is the word you can use. This is actually an EMC Clarion CX3 storage array. See this picture. This is how it looks like. This is how it looks like. It is so as big as what you see here. This is how each of these is actually disks, arranged disks. It can be empty. It may be filled with. So typically companies buy like this, and then they keep on adding drives to this enclosures. There will be in between somewhere there will be the controllers in the back of it. This is actually, I can say this is a EMC Clarion CX381. That's the name of it. It's a Clarion system. EMC as another, these are these Clarions are like, I would say, a mid-range kind of storage. It has some features. It is a very, very famous product. But EMC also has something called as EMC Symmetrix. That's another. It was called as Symmetrix. EMC Symmetrix is also there. You can see Symmetrix. When it comes to Symmetrix, it's much more bigger boxes, very costly. It has some other technologies built in. Maybe the advanced storage concepts and advanced performance and automated tiering and things like that is also built into Symmetrix system. Clarions are, I would say, the juniors of junior. If you talk about this. If this is like 100,000, not 100,000, if this is like probably a $700,000 or $800,000, Clarion you may get it for 300,000. So you can see that the huge price difference. This is how in a big company the Symmetrix are arranged. See that it's all lot of storage. This is how it will be now. My data center and all. This is how it looks like. We have We have racks and racks of storage systems in our office. So that is how the storage system is now. Today, EMC changed the name of all these things. It's no more called as Clarion. They call the Clarions called as EMC VNX. Actually, they call it as VNX. So why I'm telling all these names are because when you go for interviews, people will ask you, what is this? See, these are EMCs, a new box. These are VNX. There's a different type. Depending on your requirement, you can buy big or small. These are all EMC VNX. You can buy the smallest one to the highest ones. This is actually the new generation Clarions are called as VNX. New generation Clarions are called as VNX. Okay, VNX. There is also another set called as VMAX. VMAX is the higher end storage. It is very similar to the Symmetrix. This is the VMAX. EMC VMAX. You can see that picture here. This is Symmetrix actually. This is EMC VMAX systems. This is what we are now buying in our office. All our ESX servers are pretty much using these storage. So EMC, you need to put some name because definitely when you go for interviews, people ask you what type of storage you use. So you have to say you are using EMC, or you can start with say, oh, we use EMC. But if that guy asks you one more question, what type of EMC means, then you should have an answer for it. You should say either Clarion, or you should say Symmetrix, or at least if you are talking about the latest technologies you want to talk, you should say you are using VNX or your company just bought some VNX. That is exactly what Samrat told a few minutes back. He said, we started new VNX this week. See, many companies are just started buying VNX. It's been in the industry for almost a year now. People are just getting used to it and they have started buying. And it's not only that, there is Clarions are no more shipped. Because if you are asking for a Clarion, EMC will say you go and buy a VNX. If you are asking for a Symmetrix, they say you go and buy a VMAX. Okay? So these are different storage. You can also take, you can also go to NetApp storage. NetApp is another big company in storage. These are NetApp storages. See that, these are the NetApps. That is another big company. Network appliances. You see NetApp, they have different models and different things. EMC also has, they have something called Centera and Celera and all. I'm not going to talk about that, but we're talking about the storage array. So what are these called? These are called as storage arrays. Okay. An array of disks inside it, and there are controllers. Even in this picture, if you look closely, this is a NetApp storage. You can see in the center part, there are the controllers, or these are the servers that manage all these servers. It will be terabytes and terabytes of storage will be here. Depending on the size, you can buy for 300 GB hard drive, you can buy, nowadays even 2 terabyte hard drives are coming. So you can put one drive is 2 terabyte. You can put like that. 500 GB drives. Old days, I still remember in old days in our HP EVA, the biggest drive was 300 gig drives. But now, let us ask Samrat. Samrat, what are the biggest drives you guys use in your environment? Individual drive, what is the size? Samrat, you there? Can you hear me? Oh, okay. You still use okay. So 300 GB, 500 GB, our range. Okay, 500 GB to 2 terabyte and series. Okay, so you can use that. Okay, fine. So that is what is a general idea about storage system. So it's not the hard disk we are talking about. It is simple, not hard disk on a computer or a server. We created some storage, local storage. That is 4 or 5 disks like this. I also have some of my servers have 300 GB hard drives. You configured RAID 5. We are now talking about the next level of that, much more number of drives and things like that. That is what a real storage system needs. Okay. So this picture, this is not very clear. This is actually a photostat of the thing. You can see that the picture is not that clear. But what I wanted to explain here is this storage. This is actually the components of a storage. So this is actually the components of a fiber channel SAN. So let us keep the SAN part, let us outside. This is using a protocol called fiber channel. So when we say fiber channel SAN storage, means it is using a protocol, fiber channel protocol. It uses fiber optic technology at the back end. It's basically, you know, fiber optic technology is talking about light. So it is the fastest technology that is available. So that is what this fiber channel technology means. So it is widely used. Every company has fiber channel technology, and there are different technologies. You know, I'm not going to focus too much into that, but let us focus about components of a fiber channel SAN or fiber channel or FC. Typically people call it as FC. So the picture I showed you already, you know, you are seeing all these different storage arrays. This is called that. This is what I was showing in this picture. Whatever you saw, that big huge things is this. This is an HP EVA or EMC Clarion CX4 or CX3 or, you know, VMAX or something. This is what it is. The second part of it, it consists of some fiber channel switches. You know, when you talk about, because here we are using fiber optic technology, we are using a protocol called fiber channel protocol. It is not TCP IP or it is not Ethernet or anything. So we are using connections are all fiber optic cables. So there are switches and all that to manage these fiber channel connections. And those such switches are, you can call it as fiber channel switches or FC switches. Cisco has some series. Brocade has switches. Brocade and Cisco are probably the leading companies that makes fiber channel switches. Cisco switches are called as MDS, Cisco MDS switches. There are many there, but you know, I'm not very familiar. I'm not a SAN guy. Remember that also, guys. Okay, let me close this. Cisco MDS switches. If you look here, you can see that these are actually fiber optic switches. You can see that these are all fiber optic cable. This is how a fiber optic cable look like. This is the picture of a fiber channel switch. You can see the picture of that. This is not the Ethernet cable. Okay. This here you put fiber channels cables. You can put into that. Okay. So all fiber channels. Cisco has different type, different series. So these are called fiber channel switches. Okay. Okay. Yeah, speed 10 GB, 4 GB, you know, you can have different speed, bandwidth and all. So anyway, so this is what that switch is. That is how the switch is. So in a fiber channel network, sorry, you will have these switches also. Then you connect these switches to your ESX servers or your Windows servers or your Linux, Solaris, whatever servers, you attach them to this storage array using these fiber channel switches. You cannot simply attach, you know, if you have a network card, you can connect it to the network switch, but if you want to attach your servers to a fiber channel SAN storage, you have to have something called as an HBA. HBA stands for Host Bus Adapters. Emilex and again forgot. QLogic are the two companies, Emilex and QLogic. There are other companies too, but most famous ones are Emilex, EMU, LUX, and QLogic. These are the two companies that makes HBAs. HBAs are called as Host Bus Adapters. So you have to put that HBAs in your server, just like your network cards. You have to insert HBAs, and then you connect that HBAs to your fiber optic cables, and you connect and you access the thing. So if your server wants to access a storage inside or a hard disk inside a disk array, inside a storage array, it has the connection has to go through here, and it will access it. We'll talk about what is this. Before that, let me talk about these things. So this is the storage array. Okay, and what we are going to look at here is the components of a storage array. So we can divide these components of a storage array into these different things. I'll talk about it. So the first thing is called as the storage system or the storage array. You can call this is the whole storage system. Okay. Inside the storage system, as I discussed, you will have a series of hard drives. It will be 500 GB or 300 GB or 1 terabyte hard drive. There will be a lot of hard drives. You saw that. There will be hundreds of hard drives in a pretty big storage array. Now, the SAN administrators, they will connect to this using different interfaces. For example, EMC, they have something called Unisphere, or Navis. HP has their own interface. They have different software or applications the SAN administrators use in order to connect to these storage arrays or the disk arrays, and they configure the disks. Configuring the disk means, if you have 100 disks, what can you do? What do you do first with the disk? Normally, when you get the disk, you club certain disks. So if I am a storage administrator, what I can do is I can take these 4 disks and make it a RAID 5 volume, correct? Then I can take these 3 drives and then I can make another RAID 5 volume. Then I can take these 2 drives and create a RAID 1 volume. Or maybe I will take the first 32 drives and then I can make it a RAID 5 volume. It is up to the storage administrators how they want to cut or create RAIDs inside a storage system. See, storage, learning storage and managing storage itself is a huge topic. That is not my goal here. My goal here is to give you guys an overall idea about a storage system and how that is working. There are different technologies and different, if you talk about, there are RAID groups, there are LUNs and meta LUNs and concepts, and all lot of things are there. And even the newer technologies has even having a whole different architecture. Automatic tiering of storage and things like that. So we don't need to get into that. That is the job of a storage guy. And being a VMware administrator, we don't have to worry about that. But we should have a good understanding of what a storage array is, what this technology is, and how it works. That is what my intention here to teach. So this is what a storage array is.
Deepu, question. You said you can create RAID out of few disks and things like that. RAID is for redundancy, and if one disk goes down, you can replace it. What if the entire array itself goes down?
The entire array, if it goes down, it is done. But entire array means, what do you mean by the entire array goes down?
Like what I'm basically asking is, your data is protected if you have RAID. But since you're putting all hard disks in one array or one rack, let's say something bad were to happen with power and the entire array goes down. So all I'm asking is there a backup?
It won't be in one array. It may be in 2 different, maybe in multiple. If something like that happens, if anything can happen, right? But in a storage array like this, nothing will happen. It is so powerful things. It has different power connections. And there is also see, RAID 5, I'm just giving an example, okay. There are, UPS and all those things, so there is no question about a system going down. It can fail, a motherboard can fail, a processor inside a RAID array can fail. The whole RAID array going down is not a case. I don't think if something like that happens, there is no way to control that. But if you have, you have some expectations, right? For example, you are creating a RAID 5 array or a RAID 5 volume. So in RAID 5, why are you doing RAID 5 for redundancy? Because if one disk fail, you can still get the data. But if 2 disks fail, what happens? You lose everything, correct?
Mm-hmm.
So if that kind of a situation happens, you lost everything. So, but chances for that are very, very, very less. But again, there is some more concept is there. in a real RAID, it is that is why I was using the word meta-learn. Let me see, I can, let me try to put it. So let's say, you have some arrays like this. You have some, I don't know how much picture it will stay here. It may go off. Let's say these are all drives. So they create a RAID file volume here. Then they create another RAID file volume here. Okay. So in these RAID files and all, you can have one disk fail. You can still work. And there will be another RAID file volume here. I'm just giving a simple example here. So now they created 3 RAID file volumes. And then they chunk this RAID file volumes into another categories like this. That are called meta-learns. So when you come to a real storage thing, it is not just making a RAID file volume and giving it to you. It will be taken from different RAID. If I'm giving you 100 GB, that 100 GB is not coming from one RAID file. It may be coming from couple of other RAID files that are called meta-learns. I'm not going to get into that detail, but since you asked, I'm saying. So there is a possibility that you may lose the whole RAID file volume, but since you create meta-learns across multiple RAID file volumes, you are more protected in that case. So there are many steps storage administrators take in order to protect that. But if you lose a whole storage array, then that is I will call it as a disaster. There is no other way. But I don't think that can happen in a situation unless otherwise a natural disaster or something happens.
Okay, thank you.
Okay, so Aravind or Samrat, do you want to add something to that question? I mean, you guys more storage guys. You want to add something?
Yeah, basically like something. Yeah, real quick. Like at any point of time, you have the backups. If it is like your failover or like in your passive, whatever it is, if something really goes bad, all you have to do is recover from the backup site, or you call it as a disaster recovery, or it comes as a part of the DR and business continuity planner. So you have to get it from the backups.
Okay. All right. So we talked about the storage system. That is the whole system. Whole system is not the whole thing. This is called as the storage system. Then comes the storage system, as these are the smaller components inside that you have the different hard drives. And as I said, the RAID administrator, the STAN administrator can create RAID volumes out of it. And again, multiple RAID volumes clubbed together and they create a chunk of small storage that is called as a LUN. LUN is called as logical unit number. LUN. It's a very common term that is used in the industry. LUN. LUN stands for logical unit number. That is what this is. So this is actually a LUN. This is one LUN. This is another LUN. This could be a 100 GB LUN. This could be a 10 GB LUN. This could be a 1 terabyte LUN. That is depending on your request. So if I am asking our storage guy, hey John, I need a 1 terabyte LUN for my ESX server here, then what John will say is he will go and create, or he may already have it there, I don't know, but according to me, he is going to take some drives, probably it's already created there. He will create a volume and instead of that, he create a new LUN for me. This will be the new LUN and he will present that LUN to my server. And now my server can see a 1 terabyte hard drive. You getting? That is how the SAN technology works. So these are called as SAN LUNs or storage LUNs. In this picture, you are seeing 3 LUNs there.
So
then comes the storage processor. Okay, go ahead.
So LUN is basically a RAID volume, right?
Yeah, you can consider it. It is basically a RAID volume, a chunk of a RAID volume. It may not be a one-to-one. When you create a volume in a local storage, if you have 4 drives, you create 1 volume. But when it comes to storage, you cannot say it that way because in a storage array, the storage administrator might have taken 30 to 300 GB drives and he create a big volume. And then from that big volume, he give you a small piece of that. That is why it is called as logical unit number. It's a small chunk of the big volume.
Okay.
For VM, who decide what RAID level is required? The VMware administrator has to decide, depending on it is not a easy call. You have to understand the what that VM is used for, what are its IOs, and what is it read intensive or it's a heavy hitter or things like that. Based on that, you have to decide in which LAN you want to keep that VM. So you can request your storage administrator whether you need a RAID 5 or a RAID 10 or a RAID 50 volume, but that is a different thing. But once you get the LAN, it is up to a ESX administrator to decide which VM should go to which volume. That is, an ESX administrator has to make that call. For example, in our company, when we have SQL Server VMs, we put them in a separate type of LANs. That is a high-end LAN. Maybe it is much more faster drives. It may be RAID 10 volumes or RAID 1 volumes, things like that. Storage processor. I mean, it's a general thing. It's mainly called as SP. These are actually the controllers of your thing. It's not actually the controllers. I should not use that word. Storage processors are basically the interface or to the storage array, and this is where you do all the processing. It is actually that brain of the whole storage array. I mean, it is much bigger term, but I'm putting it in a very small term. Just understand that this is that controller that do all the magic. So basically, a SAN administrator connected to the storage controller and do that. A storage processor is actually where you connect your fiber optic cable to your SAN system. This is the interface for the SAN system. Then comes the fiber channel switches. So if you have, for example, let us say in my company we have a ESX, we have a storage array. The storage array has so many drives. And from that storage array, okay, let me put it in a paper. I don't think I can go it here. Okay, let's take an example here. Let us say this is your storage array. This storage array has so many drives. And the SAN administrator, out of these drives, he created some storage volumes. Let us say this is your storage processor, two storage, that is the interface. And I have an ESX server here. I'm asking, I can do one thing. This ESX server will have the HBAs, correct? We all know that. Typically, every server will have 2 HBAs. Why do you need 2 HBAs?
Redundancy.
Why can't you do? That's all just for the purpose of redundancy, okay? Because if something goes wrong, basically your computer will be running without a storage. So you cannot imagine a condition like that. A server without a hard disk means it is dead. So there is definitely, you have to put always 2 hard drives. So I can take a fiber optic cable and I can connect it directly to this HBA. I can take a fiber optic cable and I can connect it to this server. Now my server can see what? These storages, correct? The same 3 storages, whatever we are talking about here. These 3 storage, if it is permissioned properly, I can see them right on my server. If I log into the server, I can see the storage. This is the SAN array. Fine, this is okay. This condition is okay. But now my question is, I have one ESX server here and one ESX server here. Now tell me, how do I connect these servers to the SAN? This SAN has many storage. It is a big SAN. It's from EMC's Clarion CX4 or CX3. It has so many LANs created by my storage administrator. But how do I connect these 2 things now? How do I connect my 2 more ESX servers? I have 2 more ESX servers. That is where you need a fiber channel switch. Otherwise, you need to have many storage controllers here. That is not possible. And you can put maybe 1 or 2. There are the newest ones are coming up with 8 controllers and all, 8 storage processors. Some are coming with 4 storage processors. But that is not a practical solution. In our company, we have 1,000 plus ESX servers. If I want to connect all that 1000 ESX servers to our storage array, then you can imagine. So that is not possible. So you have to have a switch in between. A fiber channel switch needs to be put in between. That fiber channel switch will have a lot of ports. It can be 24 port switch or 48 port switches. And now you can actually connect your switch ports to here like this, like this, and you can connect. Now you can connect all your servers, right? And they all can talk to the thing. So the fiber channel, the administrator said, okay, these two green LUNs belongs to this server. So the green ones go here, the red ones go here. He said, okay, the blue ones go here, so the blue ones will come to this server. Okay? This is how you present. Then again, there are permissions and things like that. Now, it is not shared storage. This is not shared storage. Here I am giving storage directly to the servers. If you are looking at this picture, it is not shared storage. This is a storage here, but this is not called a shared storage. Okay, Fanny? I mean, I know what you meant. I know you might have put it in the wrong time. That's it. But this is a storage array, and I'm giving individual storage to this. We have some file servers that are standalone boxes that have 2, 3, 4 terabyte storage dedicated to them. That storage is not shared by anybody. This green storage is dedicated to this box. Only this green server can see that green storage. Only the red server can see the red storage, and only the blue server can see the blue storage. Okay? So this is the thing. That is why you need a fiber channel switch. You understand, right, what the need of a fiber channel switch. The fiber channel switch will allow you to connect. And now remember, all these communications are happening through a protocol called what protocol? Is it TCP/IP or is it any other protocol? It is using a protocol called Fiber Channel Protocol, FC protocol. That is why this whole system is called as a Fiber Channel SAN. So your entire system is called a SAN. So a lot of people think that this is SAN. That is not correct. A SAN is actually consists of the storage arrays, the fiber channel switches, the HBAs, and all these things together is called a SAN. Storage Area Network. So that is why this is whole system, you can call it as a SAN. Okay? Not just this. This is actually a storage array. There's a lot of people think that the storage array is called a SAN. That's not correct. Yeah, you can call the whole fig picture is actually a SAN. That is correct. It can be multiple pictures like that. It is still called as a SAN. In our company and all, we have multiple storage arrays. I will come to that point in a minute. But this is one storage array attached to 2 servers. But one storage array can satisfy 100 servers or more servers. In our office and all, we have many storage arrays. Not one storage arrays. We have many storage arrays. They are all connected using different switches, and hundreds of servers are attached to those storage. The whole system, you can call it as storage array. Anyway, I'm coming to that. So you can have multiple switches. Why do you need multiple switches now? See, here you can see that there are 2 switches. This is one switch and there is another switch. Again, redundant. So this is not a good connection. This picture is, I won't say this is a good thing. So typically what you should do is, okay, I'm going to adjust on this. Okay, so typically in companies, this is how it is. There will be a storage array. And out of this storage array, let's say the storage administrator created some LUNs. Let us say this is having the 2 storage processes. And let us say you have some ESX servers here. 1, 2, 3, 4 ESX servers. Now, earlier I was showing only one switch. That is not correct. You should put at least 2 fiber channel switches, redundancy purpose. Every server will have, this is how called multipathing and things like that. We will see that, It can be as complex, and then that is what the challenge of a VM storage administrator, to manage this network. Creating these LUNs and all is one part of his job, but managing this fiber channel network is actually one of the primary job of a storage administrator. They are physical connections, yes. So here I'm going to take one connection from here, goes to this, and this is connected to this, and this is connected to this. Now my next connection from here, this will go to this switch. This will go to this switch. This will go to this switch. This goes to this switch. This goes to here. This goes to here. This is how it is done. Now, even if I lose this switch or this path or this storage controller or even this HBA, my server can still access the storage because I have complete redundancy. This switch will be connected to one power supply. This will be connected to another power supply. That is how a good company's redundant system is built. If you connect both your HBAs to one switch, and if that switch fails, it is your problem. You may lose your job also. So you have to be very careful, and you have to. That's why proper labeling and naming of every component in a data center is very, very important. Even in our data centers and all, we use even color coding. Means the cables itself, blue cables go to right, orange cables go to left. So we in fact use the cables also color coordinated cables. So that way when one person comes, he can understand, okay, red cables are going to the right, blue are going to the left. They know that everything clearly, even though they are labeled. Because it becomes so messy when you go to a data center. You are talking about thousands of connections. Okay, so these are now you have multiple fiber channel switches. That's how you do that. And this is a simple picture I'm showing. There are only two FC, storage processors. In newest ones and all, you can see there are more storage processors. 4 and 8 are available. So a combination of our multiple fiber channel switches or that fiber channel network is called as a fabric. So when you go, so we have fabric A and fabric B in our data center. Fabric A is one side and fabric B is another side. That's a little bit more getting into the details of it. But anyway, don't worry about that. This whole system, this particular picture, you can see that in this picture here. This one is called as a fabric. The fiber channel switches, or it is called as the fabric. So a combination of fiber channel switches is called as a fabric. And then talking about the HBAs. HBAs, I told you QLogic or why am I forgetting that? Emulex or QLogic, I don't know. It's something, sometimes it's like that. So Emulex and QLogic, they are the two different HBAs. How many of you have seen HBAs? Real HBAs. Some of my servers have HBAs, even though I don't have SAN, but I have HBAs. How many of you have seen HBAs? Okay, 3 people I expected. Okay, nobody else has seen HBAs, correct? Let us go and look at how an HBA looks. This is an HBA. This is a QLogic HBA. On a first look, you may think that it is a network card, but it is not a network card. It is a fiber channel connection. You can see that this port is not a RJ45 connection. It is actually the fiber channel. There are names for it, and all. I'm not going to get into it to confuse you. So this is actually a HBA. You get dual port, single. This is a single port. You can see dual port HBAs. So this is how it looks like. And you connect the fiber optic cable to these ports here. But this is how it is. If in a real HBA look like. There are, if you talk about Masonic cards and all in a blade, it's a whole different story. But when somebody tell you a HBA, this is what the picture that should come to your mind. This is an HBA. This is how your server can have different HBAs. So dual and both HBAs are available. So QLogic and the other one was Emilex HBAs. These are another company's HBAs, Emilex HBAs. This is what Emilex looks like. It's pretty same, saying these are HBAs. Okay, that is an HBA. So those HBAs you should put it on your Windows servers or ESX servers, and then that's how you provide. Any questions on this particular, whatever I talked so far? Any questions? Okay, so moving to the next page, okay. This is pretty much the same picture, but it is little much more to address, how fiber channel system work. There are certain terms and things which I think you should all know. Because when you talk to a SAN administrator, if you go and talk to SAN administrator, you should have at least some knowledge about a SAN, a fiber channel SAN system. So this picture is actually a little bit concise version of the what picture earlier. Here they are only showing one fiber channel switch. It's not showing as a fabric. There is only one storage processor and there is a disk array. You know what it is. A disk array should contain. They are not showing the actual physical drive. They are only showing the LUNs here. So you can see that is a LUN. There are LUN 0 up to LUN 12. There are some dots in between. So there are 12 LUNs in this, or 13 LUNs in this array at this point. They are showing it. According to the picture, it says LUN 0, LUN 11, LUN 12, and then there are some dots. This is the storage processor, and this is the fiber channel switch. This is the HBA. This is the ESX server. You all know that, right? Now, one important thing, there is a word called WWN. WWN means worldwide name. It is a unique 64-bit address assigned to your HBAs. Every HBA in the world manufacturer will put that number. It's a unique number, very similar to the network card's MAC address. In network card, we call it as MAC address. In HBA, you call it as a WWN, worldwide name. Right, and what are you asking? HBA card, what do you mean by that? Okay, so every HBA will have the 64-bit unit. So this is a WWN, and this is another WWN. And you know that, the fiber channel is connected to the SP. The SP also will have a WWN. Basically, SP is also a kind of an HBA. Okay, so you should think in that. It's not only HBA, it has many other things, but it also has an interface. So that interface also has a WWN. So in this picture, you can see there are 3 WWNs. Is that clear? Now what I'm going to talk about is there are 2 concepts are there basically to present LUNs. There are 2 technologies typically the storage administrators use. One is called as zoning and the other one is called as LUN masking. So what is LUN masking? What is zoning? That is what I'm trying to explain. Okay. So here you can see that ESX server, this ESX server is presented to LUN 11 and they are calling it as mask LUN 11. That means LUN number 11 is actually configured to use with this server, explicitly for this server. And here it says mask LUN 12, that means LUN number 12 is actually given to this server. LUN 0 and others are probably given to some other service, may not have given to it, but in this picture, from looking at this picture, I know that LUN 11 is configured to this server and LUN 12 is configured to here. They are calling it as mask LUN mask. So LUN masking he can read this here. It is done at the SP level or the server level. It's typically done at the storage process. So in the SAN system, the SAN administrator, he has an interface, he has a tool to do that. In that thing, he will actually say, okay, this LUN number 12 is given to this server. When he say it is given to this server means he is not giving the name of the server or anything. He will do some arrangements, and in this setting, in his tool, he will say this WWN can only see this LUN. It is kind of a permissioning. He will say that, okay, this WWN can only see this LUN. So when this HBA makes a request, and when it comes to the storage processor says, okay, everything is good, you can only see this LUN. That kind of a configuration is called as LUN mask. So LUN masking is typically done inside the storage processor or inside the controller inside this. That is what a LUN masking is. So typically SAN administrators do that to present a LUN to a server. So if I have a new server and if I ask John, hey John, I need a LUN, John will either ask you, hey, give me the WWN. Nowadays, you don't need to do that. In old days, we used to give, but nowadays, as soon as he connect, the new tools which he use, he may have it is called as Unisphere in EMC. There is a tool. In that Unisphere, he can actually see the WWN here because it automatically publishes and he can see the WWN and he will mask that WWN to a particular LUN. Size of the LUN created by SAN admin as per requirement or set standard LUN size. No, Shri, actually SAN administrators typically they may say, no, it's not true. LUN sizes are done based on your request. For example, when I used to work on 2003 clusters, for the quorum drive, I used to ask for a 500 MB LUN, 500 MB LUN. Today, when we have 2008, the quorum concept is completely changed, but still, for mount volumes and mount points and all, we use 1 GB LUNs for mount points, and then we use 500 GB and 1 terabyte LUNs for larger file volumes. In VMware environment in our company, we have a standard of 1 terabyte LUNs across the board. All ESX servers always get 1 terabyte LUNs. But not always. There are certain cases. For example, recently I had a request for a VM with 2 terabyte drive. That VM needs 2 terabyte D drive. It is a Windows server. It is a VM, and that VM requires a D drive which is 2 terabyte in size. In that case, I have to ask for a 2 terabyte LUN. So whenever I ask, the SAN administrator give me a LUN based on my request. It's not their standard. Yeah, go ahead.
Yeah, I asked that question because I always fight with our storage guys to give it, like I required a 2 terabyte, but they gave me 4 500s. So, they set a standard, they can't go more than 500.
No. I mean, that is not correct. They can give larger LUNs. They can actually give, today's technologies do that, they can do that. There is actually another concept called extents. Okay. So there are some advantages also that if you, rather than giving a large LUN, giving smaller LUNs can improve performance, can improve certain other things. There is something called extents, we can talk about that. So see, Samrat is saying you can make larger LUNs more than terabytes. So you can create. It is not that you cannot create.
What they say is they can create, but its performance goes down. So that's what I was.
Oh yeah, I agree. That's what I was telling. So we create something called as extents. But in VMware, there are certain cases when you need large LUNs. There is, you may not go for that kind of thing. But if you are talking about real performance and all, then you may have to do combine. But again, for example, if you need a 2 terabyte LUN on a Windows server, what do you do?
2 terabytes LUN for a separate storage or the OS drive?
For a D drive, let's say I have a file server, okay? that is going to store all my company's, half of my employees' home directories. It is going to be it's a cluster which is having I need a second drive which is going to be a clustered drive for storing my users' home directories. I need a 2 terabyte LAN. So your company, you are saying that is not, that's not be done. It should be cut into smaller 500 GBs.
Yeah.
No, that is sometimes, I don't know, but that is not the case. I have worked myself with much larger LANs, with today's requirement.
When they said that, I felt, I should have something, RAID option on the hypervisor,
No, you may have to check with them, but I don't think that's correct. So in our office, I told you, most of our ESX server, in ESX server case, the LAN size, the standard LAN size I always ask is 1 terabyte, or that is actually per my design. We have done that. Okay, 1 terabyte should be our LAN size. If that 1 terabyte gets filled, I will ask for another 1 terabyte, another 1 terabyte, another 1 terabyte. I can go like that. But at that point,
I'm sorry, you just present the terabytes every time the space increases, you just present to this OS as
correct,
right?
Correct.
Oh, okay.
But when there is a request, so let's say, last week we have a SQL Server request queue. They wanted to put a SQL Server as a VM.
Okay.
And in that VM, they are planning to store a large database which is almost 1.4 terabyte in size already.
Okay.
And you know that a database is that MDF file is one single file. You cannot break that into 2 drives, right? It has to be in 1 drive.
Exactly.
So in that case, and we're expecting the future growth, we decided to go with a 2 terabyte LAN format. Okay. VMware support up to 64 terabytes. Okay,
right.
And you can create a LAN up to 64 terabytes in size in VMware. So that is possible. I don't know why your administrator said that. Maybe you have to check with them, but it is possible. Anyway.
Right. When you're doing SQL Server, you're asking for 2 terabytes. Say, let's say you put it. So did they put the RAID 10 for you on the back?
Yes.
Okay. Because if the arrays are not configured,
no. In that particular case, I don't know the thing. See, it is possible for them to put RAID 10 or RAID 50 or whatever. But in that particular case, since I remember, I'm telling that was a highly read-intensive database. So that was used RAID 5 actually. RAID 5 or probably RAID 50. I'm not sure.
Right. I'm seeing the questions also. I'm asking the same questions here. I also seen people are asking in the GoToMeeting. Yeah, basically, if the disk arrays are already configured with RAID 5, and you go and ask them, give me RAID 10, they won't be able to do it.
No, that won't be a case. Only a poor administrator, SAN admin, only do that. See, in a large SAN system, right? They will have a lot of reserved disks here. You can ask Satya or somebody. They will have many disks that are not at even pool. That's called as they are not in the pool. They create some LANs and they keep it. But in case they may have, probably this guy may have probably 5 terabytes available. So if somebody asks for a LAN, he can immediately cut. But that is the time Deepu is coming and saying, you know what, John, I need a 2 terabyte RAID 10 LAN.
Right.
See, it is not that he is not going to give me that day. It is a service request I have to put, and that service request has to get approved. If there is no storage, he will inform us. Then we will have a discussion about the team. Then they will buy a new storage array. They may buy more disks, and they will carve out the new LAN using the new drives. And it takes a while. Probably it may take a week or maybe 2 weeks. You don't know. You cannot just go and say, give me 2 terabyte LAN. He's not going to give you all the way down. Right. Even in a normal case in our company, to get a 1 terabyte LAN, I have to put a request 1 week early.
Got it.
See, that's Arvind saying. Typically, we use less than 60% of storage space. So nobody configure the whole storage. As soon as they buy the storage, they're not going to configure the whole storage and make LANs and keep it like in a shop and anybody comes give it. No, they don't do like that. So they do it in a proper way, and they also do some shuffling and all in between, depending on, because sometimes you can see that some portion of the array may be getting more hit because of the IOPS and stuff like that. So they may need to shuffle. They may move volumes between. There are many things they do. That is what the whole job of a storage administrator is. It is
Well, I was doing one of the VDI project. I said I created a straight VM. Like how we're creating a virtual machine on VMware on a Citrix Zen server. I created a VM. It's all desktop VMs, Windows XP or Windows 7. And when I created on a local disk, it performed so good. But I need a shared storage. So they gave me NFS first with great difficulty. When I put an NFS, 1-2 users were fine. When I added 50 users, it was very sluggish. They could not even connect and do anything.
Very true.
Right.
NFS,
So,
I'm going to talk about that. NFS, NFS is not a high performance storage. It is specifically, the technology behind NFS. NFS is a file-based storage, whereas IceKC and Fiber Channel technology are block-oriented, block-level storage.
Block level. So
reads and writes are block-oriented.
Right. So I said, if this won't work. So they gave me said they were going to add HBase. I said I added HBase, and I got the SAN storage attached. I said, what type of SAN storage you gave me? Oh, we put you on a Clarion. Again, there also I had a problem.
It could be a game problem because in Clarions, that is true. See, you can buy SATA drives. In our DR environment, okay, we have a disaster recovery environment where we have to keep a copy of all our production class VMs. We are using SATA drives. It is because of the financial problems. We bought low-cost drives. These are 10K speed, low-performance storage. Okay. Those storages does not handle that. Maybe the SAN array itself, it's a Clarion you said. Clarion may have an old processor. Is it Clarion C700? Is it C3X? It's just like our processors, the G7 and G8. The old Clarions and all are running very old processors. These are also Intel processors running it. So if there is low processors, they also have something called as a cache. And that plays a major role because most of the time the active IOPS are getting right into the cache and then it writes back to the original disk. So in today's world, the new VMAX and all, it has much more features to enhance the performance. So definitely, so many factors. It's not just that, somebody say, okay, my storage is in Clarion. It doesn't mean that you're going to get that best performance.
Now the next move is to go to the VMAX. We already have VMAX, but
it's not only VMAX. So you should ask him what type of storage they are using, what type of drives they are using, what type of RAID they are using. All these can be questions. Then if performance is coming to, and there is also a major drawback I'm seeing with the storage administrators is this. Let me explain. Since it looks like you guys interested, let me just explain that. That's another scenario I'm talking. For example, let us say in our company we have a storage array. And this storage array, there are many LUNs, right? Many LUNs. Let's say these are the LUNs. And let us say some of these LUNs are red LUNs, which are used in VMware environment. And these are some LUNs used by some SQL and Exchange servers outside of VMware environment. So the green ones are, let us say, Exchange servers. And Exchange servers in my company are real physical servers. So these are the two Exchange servers. The Exchange databases and all sitting in these LUNs. And these are my ESX servers. They are also connected here. And I have many VMs here. And all of a sudden, I started seeing alerts from vFoglight and our System Center Operations Manager. I'm seeing latency, and I'm looking at the ESX server performance. I can see that the storage is crying. It's literally the storage is actually having pathetic latency problems. So I contacted my John. Hey, John, what is happening, John? The storage is big problem. the thing is. So he looked at it and he said, Deepu, no, I don't see any problems. Your LUNs are all looking good. When I look at it also, I'm seeing the LUNs are all good. There is not much activities happening. These are all normal VMs. These VMs are very less IO VMs. All these VMs are simple VMs, very small VMs. Nothing much. There may be some domain controllers or maybe some web servers or app servers. But I'm seeing heavy problems. The problem is, in this kind of condition, is called as an external workload. This storage, he has given it to some external workloads. My monitoring systems cannot measure what is happening on these arrays. My VMware monitoring softwares can only look at the VMware LUNs and the ESX servers. It does not see any problems because those LUNs are all okay. But in the back end, the whole storage array is having problems because these green ones are heavy hitters, are creating problems. So these are things you need to discuss. I think a smart storage administrator will have some clear plans. He may not share he should not be doing that. He should be giving these LUNs dedicated to this, and this should be external, maybe from another storage. There are many things can contribute. So what I'm saying is, it may not be, you may be seeing slowness here. That may not be because of the ESX service problem. It could be because of an external activity happening on some external storage. In this case, I'm seeing this performance problem not because I have problem. It is because these Exchange servers are hammering this storage. You getting what I'm saying? So it could be many factors. Yeah.
Yeah, sometimes they hide it because unless you are going
to
your storage.
Yeah, they do. But we cannot blame the storage guys always. In fact, Windows guys are also Windows or the server administrators are also causing problems. For example, I'll give you a good example here. In our environment, we have a VDI environment where we have a problem. It's not actual VDI though. It's actually a lot of workstation VMs. I have around 1,000 plus VMs on it. These are all running Windows XP and Windows 7. Every Saturday night, we're seeing heavy storage activities. Many batch jobs are failing. Many servers are failing. We had issues. We started looking into it. And we see that these 1,000 VMs, these 1,000 Windows XP and Windows 7 VMs, they go for a antivirus scanning at 9 p.m. every Saturday night. So you can imagine, antivirus scanning means it checks every file. It is a file read and scanning of every file in your VMs. 1,000 VMs are getting antivirus scanning at 9 p.m. in the night. So you can imagine how much activity is happening on the storage. So these kind of unplanned activities or not well-planned activities, what the workstation guys should have been done was, they should have split that load across the board. That is one kind of problem. There is another lot of things. A lot of people think that night time is the best time to do their jobs. But actually speaking, from a storage perspective, night time is the most busiest time for a storage environment.
Yeah,
backups are happening, antivirus scannings are happening, major batch jobs are happening. All these major jobs happen in the night. So, but it is a practice of the Windows and Linux administrators that they push their major jobs in the night so that during business hours everything will be good. In my environment, I very well know that the production environments, the storage systems are much more good during business hours, but they go crazy during night. Okay. All right, so let's move forward, guys. We have a little bit more. I just need to finish it. So this is actually, so now coming to zoning. So zoning is actually another technology that is done not at the storage processor level. It is done at the switch level. So what is zoning is, I will explain. So masking is one thing, you know that masking gives you. So normally when a storage administrator configure the things, as to good storage administrator, they do both zoning and masking. Satya, do you do that? Both zoning and LUN masking both together, or you guys do only one? Both are actually needed depending on this kind of situation. Let's say these are the ESX servers, these are the different SAN arrays, things like that. So I have some LANs here, I have one LAN here, I have some LANs here. These are the fiber channel switches. Let us say these are the fiber channel switches, and let us say these are the ESX servers. Now, or ESX or Windows servers or whatever, these are all different servers. Now the problem is here is this. Let's say this red one gets this red LANs, green one gets this green LANs, and the pink one gets the pink LANs. The question here is, so now that these servers are attached to these fiber channel switches, I'm just putting the picture very badly. Okay? I'm not using any color combination of anything. So you know that this is how a multi-pathic this is connected to. Every thing will have connection. This is how a good this is how a fully redundant environment is, right? Now, this is how the connection is. I'm saying in everything has connection to both switches. Now tell me, this red ESX server, can it get a LAN from this array? This is storage array 1. This is storage array 2. This is another storage. Now we are talking about multiple arrays here, okay? Not one SAN and this is multiple storage arrays. The whole thing is SAN. This is a fabric, but these are multiple arrays. This is Clarion. This is VMAX. There may be something else. This may be NetApp. But these are all different storage. They're all connected to here. Can my red ESX server get a storage from 1 and 2? That's my question.
Yes.
It can. Any server can get storage from anywhere else. So basically that is, storage is very critical environment. You don't want unnecessary people coming there and reading or attaching or accessing something. So what this VM, so in this particular case, if this is the case, if Samrat is the administrator, he will create a rule in this. There is something called vSAN and all inside the thing, I'm not talking about that, but he can create a rule inside this switches, something like segregating the thing. He can say that this HBA and this HBA of the green server, he will explicitly say a rule saying here, these two HBAs can only see this storage processor. It cannot see this storage processor and this storage processor. That kind of a setting is called as zone. Now explicitly he said, okay, you cannot see these two storage. Because he can leave that open actually, but the problem is, unnecessarily this server will make a request or it may try to scan here, there is no LANs given to it, but still, why do you want unnecessary servers going to another thing? We don't want the red server to go here, neither here. We want the red server to go to SAN array only 3. So that kind of a setup, I'm talking from a very high level, okay? I don't think I need to go that level, but zoning is done at the switch level to segregate the servers from different arrays. LAN masking is done at the storage level to assign a particular LAN to a particular server. In both cases, zoning case or in the LAN masking case, the WWN is the parameter that they use in order to permission it. In the fiber channel switch, they can see the WWNs. In the WWN, you say, okay, this WWN can see only this WWN. It cannot see this WWN or this WWN. You getting what I'm saying? That is called That is called as zoning in a very nutshell. Is that correct, Samrat? Okay. So that is how what is done. So now you understand what is LUN masking and what is zoning. Guys, believe me, this will be an interview question. If you go for a question, I mean, not an interview question at the first phase, but when you start talking questions in a nice way, you know, if a guy coming to me for an interview, and if I will ask first of all, hey, what is a WW? Okay, WW. Okay, what is storage array? So when the way he talks, I understand how much, you know, he say, okay, you know, we have a fabric, we have multiple arrays and things. Probably at that point, I liked him already. Okay, this guy is good. But I just want to know how much more he knows. At that point, I may ask him, hey, you know, what is the zoning? You know, do you guys use zoning? At that point, if you don't know zoning, it's a bad thing, you know. So if you know that zoning, then I know that this guy, he's a Windows guy or he's a VMware guy, but he has a good understanding about storage. If you know this much stuff, whatever I told you now, see, I'm spending this much time to explain because this is very important. If you know this, I think you're good. You know now what a SAN is. This is all the SAN is. Then the remaining part is all you have to get in SAN management, how to create, you know, how to manage, how to do rebooting of the, you know, how to upgrade Flare code, you know, do that, you know, many things. So that is what a SAN administrator's job is. But in general, a storage technology is something like this. Especially a fiber channel storage technology is only this much. Okay. So that is it. Now, coming to one more thing. So I'm going to finish it. It will be fast. I know I'm taking a little bit more time, but I have to finish. Tomorrow is Saturday, guys. So let us finish it because otherwise, you know, I don't want to spend 4 days with storage. That's why I want to finish storage in 2 days if possible. That's then Sunday I want to finish storage. That's my whole goal here. I know we can take, if you want, we can take it. Let's take a 5 minutes break, guys. I know I'm just holding you guys. Let us take a quick 5 minutes break and then we'll come back. Just 5 minutes, okay? I just need to go and drink some water. Let's take a 5 minutes break and then we'll come back. It is interesting again, guys. 5 minutes break. Okay? 10:35 so and LUN 12. Now, the question here is, or what we are trying to understand here is, how the VM kernel understand these LUNs. How does it talk to this? You know, how do it know? That is where I was telling from the first class when I say, you know, something like this or something like this, how do you understand? That point I said, okay, don't worry about it, but once you learn this, you will know what a LUN is, you know, what LUN it is and what that is. This is how an ESX server understands the LUN. So I'm going to explain that now. Okay. So addressing a LUN, the VM kernel disk partition addressing scheme is as follows. It always starts with the letter VMHBA. That is a standard label that identifies the physical host bus adapter. So this is the VMHBA adapter. You first say that. Then this is called as the target. So it can called as a target ID. Then the LUN number, and then the partition number. So if you call it as VMHBA, then the adapter number, that is VMHBA is standard, no matter what, always you're going to see VMHBA. Then VMHBA 0 means this HBA. Then the next 0 here, if you look at it, VMHBA 0:0 means storage processor 0, that is the target ID. Then the LUN ID, then the partition ID. So if I want to represent partition 1 of LUN 12, so I'm going to draw a picture here. Let us say this is my path. This HBA is the one that is currently accessing this LUN. So let us say my active path is this, whatever you are seeing right now. If that is the path, again, this is the path. If this is my path, if VM kernel, how does VM kernel address it? I'm going to tell that now. It will be written like this. VM HBA colon 0 colon 1 colon 12 colon 1. That means VM HBA 0, that is the first HBA. From there the connection will go to SP1, that is target ID. That is why VM HBA 0 colon 1 colon, then the LUN number 12 colon, the partition which is 1, partition 1. You understand? So that is why that path. So if that is the case, can anybody tell me what is the VM kernel address for this path? I'm going to this partition 3 of this LUN. Can you type in please the path, that path? The path I have drawn here. Can you type in the path there please? Okay, I will draw this again. This is the path I am drawing. Okay, hold on. You saw that, right? This is the path. Okay. Right, and HBA is not correct, okay? That is your way of naming it. I wanted it to be the naming the way VM kernel is addressing it. I don't want Raiden's way of representing it. So you can put the numbers, guys. Okay, Sri is put VM HBA colon 0 colon 1 colon 11 colon 3. That is correct. So that is the way you should represent. So now you know, I mean, now you understand all the part. It is very easy to understand. So now if you see any LUN, you know what it is meant by, right? So this is how ESX servers understand. There is nothing much. I think if you understand that concept, that is it. What Sri has put is exactly correct. One is the LUN address. So here if you look, this is called as the LUN address and this is the partition address. If that is the case, let me ask you, if I draw this partition address, how it will look like? VM HBA colon 0 colon this. This is the path. This path is equal to this, isn't it? Yes or no? Okay, so that is how it is. So this is very important to understand, because when you are in a VMware environment and where you are seeing hundreds of LUNs, and if you have one LUN is having a problem, this may be, if you know these, you can easily identify what LUN it is, and you can go back to your, you may want to troubleshoot. It could be an HBA problem. It could be a storage processor problem. It could be a LUN problem. It could be a partition problem. So if you know all these things, you can confidently go and talk to your storage guy and explain what the problem is or which LUN you are having problem. Anyways, this is how an ESX server's VM kernel detects and understand and talk to any particular LUN. Any doubt about this? Anybody has any questions here? Is this clear? Okay, moving forward. So I think that's it, guys. I think that is the main thing. So that is what, definitely try to understand that thing in clearly. Okay. And this is something, this is all concept, but still it is, remember, if you remember correctly, when I was showing you some advanced setting of the VMware ESX server, I went to an advanced setting and I was showing you one day, when a ESX server boots up, it will scan and see only 256 LUNs by default. If you want to see more, you can change that advanced value, I said, right? So when an ESX server boots up, see, this is a QLogic card. it can only see at boot up an ESX server can only see up to 256 LUNs. 256 LUNs is a lot of LUNs. If it is 1 terabyte LUN, you're talking about almost 2 petabytes of LUN. You know, it's too much of storage there. But I'm just giving you an example. 256 LUNs is the maximum an ESX server's VM kernel can scan at the time. If you have more, then you have to do a manual scan. Okay. So it's just a point I was mentioning there. So how is fiber channel used with ESX server? So now that you know what a fiber channel SAN is, right? You know the components of it, you know how it is used, you know how VM kernel reads it and things like that. Now when you have a fiber channel LUN presented to your ESX server, what can it be used for? So first thing you need to do is you have to attach that storage to your server. So you can use, you know, if you know the SAN boot option, there is an option where you can boot your ESX servers. You have to boot your ESX server from the SAN itself. So you can use, if you have fiber channel SAN, you can actually use ESX server to boot from SAN. Some companies do that when, especially when they are having blade servers and all, they use the boot ESX server from SAN LUN. So booting an ESX server from SAN LUN, anybody know how can that be done? How can you boot an ESX server from a LUN, from a fiber channel LUN? It is simple. It is not a big thing at all. You have to go to the BIOS of that server. You know the normal boot order, right? When a computer boots, it will first boot, try to boot from the CD-ROM drive, or it will try to boot from a floppy drive, or then it will next look at the hard disk, correct? Or then there is actually PXE boot and all. You can use the network card to boot from the network. Same way, when you have HBAs in your server, you can go to the BIOS of your server and you can make your HBAs as the first boot device. Understand again clearly. Go to the BIOS of your server and make your HBAs as the first boot device. By doing that, you can actually boot from the SAN. It's not very important, but I'm just saying if somebody asks you how to do that, that is how you have to do it. So when you get a fiber channel SAN LUN, you can actually attach to your ESX server and you can format it with VMFS partition and you can create it as a data store, right? Once you format storage with the VMFS partition, we call it as data store, correct? We learned that. We made many local data stores and that is where you created all the LUNs. So if you have a, let us say you have a ESX server or a physical ESX server like this. This ESX server has some local hard disks, 300 GB and a 300 GB. There are two 300 GB hard drives. You can make this into a RAID volume. It will become RAID 1, let us say it will become a 300 GB volume. This is local storage, okay? I'm talking about a local storage here. Two hard disks, 300 GB each, and you made a RAID 1 volume, and that is here. And now you can format that into a VMFS partition. So you call it as a local storage. Now you ask your ESX server, hey, I want more storage. So he gave you 2 more LUNs. You can format them, you can attach them to your server using HBA. Now this will become another data store. This will become another data store. What is the difference between this data store and this data store? That is my question. From a server, you are going to see 3 data stores, but what are the difference between that? The difference is nothing but the first one is a local data store. That means the storage is attached to the server, that is local to the server, whereas the other 2 are external storage. Correct? So you can call it as external storage, but from an ESX server perspective, they are all data stores. You getting what I'm saying? These are from, probably these are 2 storage from an external array, right? This will be from external storage. That is, this storage is actually sitting here. The real data, real hard disk of this is sitting here. Whereas for this one, the real storage, the data is sitting inside here. That is inside your computer. So this is called as an external storage, and this is called as a local storage. But you can format all of them as VMFS partitions. Okay? All of them can be VMFS partitions. So once you create a VMFS partition, what all it can be used for? It can, a VMFS partition is used for what?
Creating VMs.
Okay. Creating VMs. Okay. Store the VMs. Now let us talk, Fanny. Let us talk a little bit more technical terms here. I wanted to hear that. It is for storing the VM state, correct? Or the VM's working directories and VM's disks and things like that. It's not just VM disk. Is it the VM disk is the only thing we keep it there, Sujan? In a VMFS partition, do you keep only the VM's disk? What is the extension of a VM's disk file called? It is called as a VMDK file, right? And we learned about different type of file system. VMDK files, VMX files, log files, NVRAM files. So that is all called as the state of a VM. So you can use a VMFS partition to store the state of a VM. Correct? Then we haven't seen that state. We can store ISO files. I was mentioning the other day, Fanny was asking, can you connect only this way? I was telling you can move ISO files and store ISO files in VMFS file system. VMFS file system cannot be used for storing your PST files or your Windows Word document or Excel file. That is not the place for that. VMFS file system is a virtual VMware file system that is used for storing virtual machine state, ISO files for building servers, and there is also something called as templates. Templates are, what is a template actually? What is a template? In a generic way, what is a template?
You can take it and keep creating copies of it, or keep creating clones of it.
That is what a template is. You can make a different clones, clones, you can say clones, yeah. Template is something that, a template, and from the template you can make multiple copies. So VMware, we're going to learn about templates. We haven't learned about templates. We will learn templates when we get into vCenter and all. So you can use that to store templates also. So templates can be stored, ISO files can be stored, and these things can be stored. Allow VM to access a raw fiber channel SAN LAN. This is called as RDM. RDM, okay, very important terminology. It is called as RDM. RDM is also called as raw device mapping. Not widely used in today's world, but it was heavily used in the past for high performance storages. That means you can present a LUN, okay, listen to me very carefully. You can present a LUN to a VM directly, not to a ESX server. Just imagine presenting a hard disk or an external storage directly to a VM. That technology is called as raw device mapping. It is not going to, you're not going to convert that LUN into a VMFS partition and create VM, nothing. The VM is there, but you can present a storage to a VM directly. This is actually required if you want to create Microsoft clusters or MSCS clusters in a VMware environment. You want to create a MSCS cluster, Microsoft Cluster Service between two VMs. You may want to do that. Those are little advanced topics I won't be discussing here, but I just put it there. If somebody asks you, you can do that. But does anybody do that nowadays? No. I have done that in my labs. I have done that for some external customers. I try to help some people to build their offices and all, but I have done that. But in our office, we don't use Microsoft clusters within VMware clusters. So it is something called as a cluster in a cluster, which is not that really Microsoft wanted to do that. Microsoft also does not support that a lot, but nowadays Microsoft do support that. Those days they call it as a cluster in a cluster because VMware itself is a cluster. In that cluster you are creating a Microsoft cluster, so there is a whole lot of complexity there. But it is possible, and if you want to do that, you have to have RDMs present. So we will see that. I will show you how to present a RDM to a VM. We will do that here by using iSCSI LUNs. I don't have fiber channel, but when it comes to iSCSI also the concepts are all same. So we can present a raw LUN to a VM, and we will do that in the class when we learn iSCSI storage. Allow VM to do migration of VM whose files reside. Okay, that is actually vMotion. vMotion is something we're going to learn. vMotion requires shared storage, but today with the latest thing, VMware can do vMotion without shared storage, but not highly recommended, but it can be done. But VMware vMotion, in everybody's eyes, if you talk, vMotion is the process of moving a running virtual machine from one ESX server to another ESX server without any service interruption. That process is called as vMotion. Again, I'm telling you, vMotion is a process of migrating or moving a running virtual machine, not a powered off virtual machine, moving a running virtual machine from one ESX server to another ESX server without any service interruption. So a lot of people say moving a VM from one server to another is called vMotion. That is not vMotion. If you can move a power off VMs like that, it is not vMotion. You can move a server from one server to another and losing all the connections and making it a full mess, and you can somehow bring it up the other side. That is also not vMotion. vMotion means a smooth migration of a running virtual machine from one server to another is called vMotion. We will be doing vMotion in the class, many vMotions. So vMotion is a technology. If you want to do that, you need a shared storage. Okay. So this is the summary of this first chapter. It took us 2 hours, but I think you all got understanding, and I hope you got a clear picture of what at least a SAN is, what is a fiber channel SAN is, what are the components of a SAN is, you know how to address it. So if you read that 3 lines, the worldwide name, you know what it is, right? LUN masking and zoning, you know what it is, correct? And you also know how a VM kernel addresses a particular LUN. Anybody has any questions on those 3 things? Is it clear? Okay, these are very important things because going forward we're going to read, learn and practice and do things based on these concepts. So that's why I'm telling you, as I said in the beginning classes, whatever we are learning now, the storage is very important. Networking, every component, whatever we discussed in networking is very, very important. Understanding every properties, the security policies, promiscuous mode, forged transmit, coming to the traffic shaping, and also coming to the NIC teaming properties of load balancing, failover detection. All those points are very, very important when we come on to the next state of when we get into the clustering properties, and also understanding that will give you a solid you will become yourself confident, and you can tell okay what it is. That is why I'm spending so much time. Once we get into the second phase, we may be able to move fast, but I don't want to move fast here, because if you don't understand these things, whatever I'm going to talk later, it's not going to be understood. So if you have questions, please ask now. Okay, how VLAN concept, VLAN will connect to storage. So what VLAN is connected? Okay, I'll talk about VLANs tomorrow. Satya, do you know what is VLAN first? What is a VLAN? Tell me. Virtual LAN. Okay. That is like, when I ask people what is DHCP, they say Dynamic Host Configuration Protocol. What is DNS? Domain name service. What is it? That is what I asked. I didn't ask the abbreviation of it. So my question is, what is VLAN actually? But you know that, right? We didn't talk about it. I told you I will talk about it, but I didn't get time, and I actually forgot. Actually, Gene reminded me about that today, and nobody asked also. So we will talk about VLANs in the next class. VLAN is very important, and that is where we need VLAN IDs. You know, what is a VLAN and what is VLAN IDs? And VLAN is something very similar to subnetting, you know, networking subnets and things like that. So we'll talk about that in the next class. Okay. But remind me, maybe I will forget because I go to next class. So this is what we're going to talk tomorrow. We're going to talk about IceCase SAN storage, and then we're going to do lab because I have some IceCase storage, I have some NFS. IceCase is something that we can go fast. IceCase is internet SCSI. So one thing you need to understand here is, I think that portion I don't see that. Let me see. Okay, so couple of things about fiber channel SAN storage. A fiber channel SAN storage is much more faster. You know, it can get into 4 GB, 8 GB, and 10 GB connection. You know, it is huge bandwidth. Fiber channel storage is accessed as block level storage. I'm not going to get into details of that, but at least from your perspective, keep it in your mind. Fiber channel SAN storage is a block level storage. That means the ESX servers and Windows servers and Linux servers, they all access the LUN as a block by block basis, not on a file by file basis. It will access it on a smaller block. Since it is a block level storage, the performance of that is much more faster. So always keep in mind, fiber channel storage is a block level storage. IceCase storage we're going to learn tomorrow is also a block level storage, which can also give you performance, high performance. But again, if you are comparing IceCase and fiber channel will be the better one, high performance storage. NFS on the third type of storage we're going to learn tomorrow, network file system. It is a file level storage. It is not accessed on a block by block level. It is on a file-based protocol. It is actually accessed as it's a file level protocol. That's the right terminology. It's a file level protocol. Because of that, NFS is not considered as a high performance storage. The performance of a NFS storage is way behind. I'm not saying that much, but it is very bad compared to fiber channel and comparatively less performing than for IceCase also. So if given a choice, my first preference for storage should be fiber channel. If fiber channel is not available, I will go for IceCase. If IceCase is not available, I will go for NFS. But there are other advantages. NFS is much cheaper. If you want a fiber channel storage, you are talking about at least $1 million investment. So smaller companies cannot adopt fiber channel technology. You know, you cannot just have a fiber. You have to buy a SAN storage. You know, that storage array itself will cost you $600,000 or at least $500,000. Then you need the fiber channel switches. You know, every component of that is very costly. And then also on top of it, you need experienced people like, you know, SAN administrators to manage that. So implementing a fiber channel solution in a company, only large companies can achieve that. You know, if it is a small company, I don't think fiber channel SAN is an option. So cost is a main factor. There is a huge cost associated with it, but it is very fast and high performing. It is block level storage. So these are all some advantages and some disadvantages of fiber channel storage. Okay. So that is it, guys. So I'm going to stop here today. You know, I talked many things. You know, please keep all these things. So Sujan, you can leave. I'm not going to take anything today. Okay, so guys, as I said, please build the boxes. We need the servers to be ready, 3 servers. 16, I will try to fix it if I get time. I don't know, but if I get some time, I will fix 16 and I will email it to one of you. You can build that server. There is no class tomorrow. The class is Sunday at 2 p.m. EST. Okay. Next class is 2 o'clock at EST on Sunday. And then again, one more thing I want to tell you. The next week, Monday, Tuesday, and Wednesday, there will be class. Monday, Tuesday, and Wednesday, most probably there will be class because I'm out on Thursday, Friday, Saturday, and Sunday. There is no class the next week, Thursday, Friday, Saturday, Sunday, because I'm actually out. So that is why I'm taking Monday, Tuesday, and Wednesday. Monday, the class probably will be starting only by 9 o'clock because I have something, but I will still do at least an hour on Monday. Okay, guys, then thanks and good night. Satya, if you have questions, give me a call tomorrow and we can talk. Okay, if you have doubts.